So here we look at our second example. So we say, okay, well, we first observe what's going on in this algorithm. So we say we have a loop here, then we have an assignment, and then we have a loop within the loop. So in other words, this inner loop is going to run as many times as the outer loops can run, and as many times, multiplied by as many times as itself. So we say, okay, well, how many times, what's this outer loop's contribution to this function? So we say, okay, well, this goes from 1 to list.len minus 1. So it goes from 1 to the number of items in the list minus 1. So we are saying this loop runs n minus 1 times if our data size is n. So what runs n minus 1 times in here? Well, we can see that this assignment will happen n minus 1 times, and this swap will happen n minus 1 times, definitely, because they're both inside the outer loop. Don't worry about the inner loop, we'll look at that now. So we can see that this is going to run n minus 1 times the assignment, and the swap is also going to run n minus 1 times over here. So how do we write this in terms of the function? Or in terms of maths, rather. We can say, well, the one runs n minus 1 times, plus the other one runs n minus 1 times, so that means 2 times n minus 1 times running time. So 2 times the amount of data minus 1. Then we have a look at our inner loop. Well, in our inner loop, we can see we're going from outer variable, so from the outer variable plus 1 to the length of the list. So on the first iteration, it's going to run n minus 1 times, because it's going to run from outer, which is going to be 1, to list.len. So it's going to run n minus 1 times. Then outer is going to be 1 bigger on the next iteration. So then it's going to be from 2 to the list.len. So it's going to run n minus 2 times, because outer is increased by 1. Then it's going to be n minus 3 times, n minus 4 times, and so on and so forth until we get to 1 or 0. Okay, so that means we're going to go n minus 1 plus n minus 2 plus n minus 3 all the way up to 1. So n minus 1 runs, n minus 2 runs, n minus 3 runs. So what can we say about this? Well, we can say, okay, we can look at some theory on the side. We have what we call a best case scenario, an average case scenario, and a worst case scenario. A best case scenario would be, for example, in this inner comparison, we have if list inner is less than list small. So if list of inner is always bigger than list of small, then this inner assignment here inside the if statement will never ever happen. That is, if list inner is bigger than list small. In other words, this is false. Then this will never happen. In other words, we have a best case because this inner assignment will never ever happen. So we don't have to count it in our complexity at all. The average case is when half of the data items are less than list small. Then we have half the number of assignments. And the worst case is when all of them are less than, then we have the maximum number of assignments. And that is the case we have to consider for all algorithms, is the worst case scenario. So what do we say? We say, well, if we have a worst case, then over here, we're first going to look at this, and we're going to say, okay, well, we can write it as the sum from I equals 1 to n minus 1 of n minus 1 times n over 2, which gives us n squared minus n over 2. That's just a different way of expressing what we said about the inner loop. So in our worst case, we're going to have one comparison, which is going to be list inner less than list small, and we're going to have one assignment. Small is assigned inner, which means n squared minus n over 2 is the complexity of the inner for loop. So we can have this happening over here for list inner less than list small, and for small is assigned inner. All of these are going to happen the number of times that the inner loop is going to happen. And this also considers the fact that the inner loop is inside the outer loop. So we're going to have 2 times, because we have the comparison and the assignment, n squared minus n over 2, which is going to give us n squared minus n. So what is our total complexity then? Well, I'm going to write it here. Our total complexity then is n squared is, okay, let's just write it like this, n squared minus n, okay, which is for the inner loop. And then we have to count what we just said about the outer loop over here, plus 2n minus 1. And this gives us n squared plus n, and then minus 2. So that is our complexity, which means our complexity is actually O of n squared, because asymptotic complexity says we take the maximum amount that we can.